Greetings to all. Today I am going to present the topic data augmentation in deep learning. Data augmentation is one of the most important techniques used in modern artificial intelligence systems. It helps machine learning and deep learning models improve their performance by creating the modified versions of existing training data. In this presentation, we will discuss the core concept of data augmentation, its benefits for model training. Different augmentation technique, advanced strategies like mix-up and GAN industrial applications, and popular implementation of framework. So first let us understand the core concept of methodology behind the data augmentation system. Algorithm strategy. Data augmentation works by modifying the existing training samples using mathematical transformations. Instead of collecting new data manually, the systems create additionally training example for available dataset. These modifications may be including rotations, flipping, wrapping, brightness adjustment, or noise injections. This process expands the diversity of the future space while preventing the original labels. Another important aspect is regularization. So during this training, random representation are continuously introduced into the data set. This reduces to overfit because the neural network is learned journalistic pattern instead of memories exacted training samples. As the result, the model becomes more stable, accurate, and capable of handling real-world variations. Now let us look the major benefits of data augmentation provided for the deep learning models. Data augmentation provides several important advantages during the model training. The first benefit is invariance. The model learns to recognize objects even they appear rotated, flipped, zoomed, or captured from the different camera angles. The second benefit is increased data density. In many real-world applications such as healthcare or scientific research, collecting data is expensive and time-consuming. Augmentation artificially increases the amount of training data available. The third benefit is improved generalization since the model sees multiple variations of the same data. It performs better than unseen data sets and reduces the gap between the training accuracy and testing accuracy. Overall, augmentation improves the robustness and reliability in the practical AI system. Next, let us explore some classical geometrical transformations technique used in our data augmentation. Geometrically transformation modify this particle structure of image while preserving the semantic meaning. One common method is rotation. The image and rotations within the certain angle ranges so that the network learning orientation independent the futures. Another technique is affine flipping, where images are mirrored horizontally or vertically. This helps to model to understand the symmetrical patterns. Rescaling or zooming changes in the image's dimensions to normalized object size across the data sets. Random cropping selects smaller region from the original image. This forces the model to focus on important local features instead of depending only on full image patterns. These techniques are widely used to computer vision applications such as the object detection and image classifications. Along with the particle transformation, we also use the photometric modification to improve the model robustness. Photometric generate changes the color and light properties of images. Brightness adjustment help to the model handling different light conditions. Contrast adjustment changes the intensity level in the image. Hue and saturation changes help the model understanding different color variations. Noise injection add small disturbance to image so the model becomes stronger and more stable. This technique helps the deep learning model work better than the real world situations. Now let us move some advanced augmentation method. Advanced augmentation technique create new training variations mix up combine two images together along with the labels. This helps the models learn better pattern. Cutout or randomizing removes small parts of the imaging during training. This forces the network to focus on the all parts of image instead of depending on only one area. These methods reduce to overfitting and improve the model accuracy. Let us see how GANs used for for synthetic data generation. GAN stands for Generative Adversarial Network. It contains two networks called generator and discriminator. The generator creates fake images while the discriminator checks whether the image is real or fake. By continuous training, the generator produces realistic synthesis images. GANs are useful in medical imaging, autonomous vehicle, and security system where the large data are available. Now let us look at some real-world applications of data augmentation. Data augmentation is used to in many industry in healthcare. It is helped to generate more medical images for disease detections. In automation vehicle, it creates different road and weather conditions for safer driving system. In manufacturing, it helps to detect the defect and improve the product quality. These applications improve the accuracy and reliability of AI system. Finally, let us discuss some popular implementation framework. Many frameworks are available for data augmentations, and fast library mainly used for image augmentations. The transformation is commonly used for Python projects. Xerox pre-processing layer are used in TensorFlow and Keras application. This framework make augmentation easily and faster during modeling. So now let us conclude the presentations. In conclusion, the data augmentation is important to technique in deep learning. It improves the model accuracy, reduce overfitting, and help model performance better than new data. We discussed the augmentation method, advanced technique, GANs, industrial applications, and implementation framework. Thank you for watching.